On today's episode, we are getting into the latest space news, including Starship is getting quote-unquote 1,000 new changes before its second test flight, NASA locks a research team in a Martian simulator for a whole year, and Blue Origin is developing a crew capsule with NASA's help. This is the space race. Starship is facing well over 1,000 design changes and will need another 6 weeks to implement them all before another test flight is possible. That is the latest confirmation from SpaceX CEO Elon Musk. On June 24th, Elon attended a Twitter Spaces event with author Ashley Vance, and during the conversation, the CEO spoke for a bit on some of the changes to his company's Super Heavy launch vehicle and some of the changes being made to ensure a better chance at getting into orbit with the next test. Thousands of changes is almost certainly an exaggeration, but Musk did give us at least one specific example: hot staging. Hot staging is a method of separating stages of a launch vehicle mid-flight, which has been used mostly by Russian rockets for some time now. Normally, when a vehicle stages, the engines stop for a few moments to allow inertia and the separation devices to slowly and safely pull the used booster or vehicle section away from the upper ones before igniting the upper stage engines and continuing the flight. Hot staging instead keeps those lower stage engines on, but begins to taper the thrust down and then lighting the upper stage engines while the two stages are still attached. This allows the vehicle to maintain a controlled acceleration, but it also runs risks, like incinerating your lower stage booster with the force of the upper stage engines. To combat this, rockets like the Soviet N-1 had large vents at the separation joint between stages, as well as extra shielding just under the upper stage engines to protect the booster. And Elon says that's exactly how Starship is being upgraded. A small extension to the first stage Super Heavy booster will be added that's basically just a reinforced vent. This will let the upper stage's jet plume be safely redirected outwards and allow for hot staging. Musk believes that this will be the most risky part of the next launch's test, which is fair. If the shielding isn't enough, the first stage booster will be blown apart, likely taking the payload with it, and if any of the upper stage engines fail to light, the whole vehicle could be blown off course. It is, however, a good upgrade to the overall design. If SpaceX can perfect the system, it will give Starship a smooth acceleration curve while escaping the Earth's atmosphere, which is usually the hardest part of a launch. And losing engines makes that attempt even harder. During Starship's first test flight on April 20th, several engines weren't engaged. They either failed to light or were taken offline by the SpaceX ground team in response to dangerous readings. Many observers believe that the plume of crushed concrete from the destroyed launch pad played a part in that issue, but Elon pointed out a bigger problem during his chat on Twitter Spaces. Apparently, the manifold that directs superheated methane into the combustion chambers of the ship's engines had sprung several leaks during the test. The Super Heavy booster had never been tested at anything more than 50% power before, and as it turned out, superheated gas at high pressure was more than certain parts of the manifolds could handle. The problem happened around the areas where the manifolds had to be bolted to the ship itself, a common spot for fluid systems to leak. The solution, Elon says, was to redesign the manifolds themselves and use a higher torque rating to secure the bolts. Musk also brought up the new deluge system, a high-pressure showerhead-like device that will shoot water upwards from a large steel plate mounted under the orbital launch mount. SpaceX watchers have been discussing this system for a couple of weeks now, so we are mostly familiar with how it's supposed to work. Time will tell, though, if it actually stops the next Starship launch from blowing a sizable hole in the Boca Chica sand. But while those are big changes involving many smaller adjustments, it's hardly thousands. However, Elon is likely talking about the changes we already know are being implemented to the Starship and Super Heavy designs. Things like swapping out the older hydraulic control units, the ones that ended up exploding on the first Starship launch, for new electric units. That's a fairly complex change that will end up solving some of the issues we saw on April 20th. We've also seen a lot of testing at SpaceX's test range at Massey, Texas, with regards to the flight termination system. At least, that's what it looks like. The FTS not operating like it should have back in April was probably the most concerning hardware failure of the day, and if SpaceX hopes to secure another launch license from the FAA, they will need to address that. And finally, we have also been seeing interesting hardware variations from newer models of Starship coming out of the Star Factory. Sightings of a strange new internal structure has had observers wondering about crew compartments and Starship lander variants, while this look at the nose cone of Ship 30 appears to have the first glimpse of a reaction control system, the delicate thrusters required to help a ship make precise maneuvers in space, like for docking. Those are indeed a lot of changes being made to Starship's design, possibly even thousands like Elon says, and they will take some time to implement properly, even if several of these changes are already complete on different prototypes. But Musk's timeline hasn't changed from the one he provided on Twitter last week in response to some questions, but whether or not Starship gets a second crack at reaching orbit in 6 weeks isn't up to him, it's up to the FAA, who is currently dealing with a lawsuit and finishing up their investigation of the first Starship launch. An investigation which is guaranteed to present a list of changes the FAA will want to see before allowing SpaceX to proceed with a second test. Like we said though last week, NASA and the US government have too much riding on the success of Starship, and we've all seen how long they'll keep a project going once they've invested in it. Just look at Boeing's Starliner or the SLS. In the meantime, let's all keep an eye on the build site. We'll always learn more from watching work being done than listening to a media event. The first real training for Mars has begun. On June 25th at 7:30 Eastern Time, a 4-person crew of NASA volunteers stepped into the simulated Mars base at NASA's Johnson Space Center in Houston, Texas, and they'll spend a whole year in there conducting tests for the Crew Health and Performance Exploration Analog, or CHAPI tests. Mission 1 will be the first to use this mock environment, and the crew will be monitored remotely by researchers and medical staff. Named Mars Dune Alpha, the 1,700 square foot 3D printed HAB structure and an adjacent Mars sandbox simulated environment were built to study the effects of living on Mars for the small crew of 4. Researchers Anka Solariu, Kelly Haston, Nathan Jones, and Ross Brockwell are the first of 3 crews who will spend extended periods of time inside the mock HAB, testing the psychological effects of living in the isolation and danger that surviving on Mars will bring on any crew we send there. These analog astronauts will be eating only food that is already stored on site and only leaving the HAB to make mock trips outside into the Mars sandbox area in their EVA suits. They'll even have simulated communication lag, their talks with mission control being delayed by 22 minutes both ways to approximate the realities of talking back and forth with a crew on Mars. The crew were selected to be as close to real astronauts as possible. They all have at least one STEM field degree. They all have some professional experience in their chosen field, or military training, of course, and they all had to pass the same physical and psychological testing as other astronaut candidates. The CHAPI experiments are all about testing for the one thing we really can test from Earth: resource restrictions. Isolation, communication lag, ration food, and the rigorous schedule of upkeep required to maintain their HAB are all forms of restriction that will affect the mental state of the people we send to Mars. The only thing that won't be tested is the length of daytime and gravity. NASA techs can easily control the day-night cycle in the simulation, but according to studies, the extra 39 minutes and 35 seconds of a Martian day really only impact mission control back on Earth, so there's no real need to test the astronauts, who will pretty easily adapt to the change. NASA can't test the 38% gravity for obvious reasons. The first test of Martian conditions might be simulated, but we shouldn't forget that these crews are still taking a risk here. Psychological damage from living in isolation is a very real threat, and it's important that we understand what could happen to the people we send to Mars when the time comes. Best of luck, Mission 1. On June 15th, NASA announced that they had signed agreements with 7 companies through their Commercial Space Capabilities 2 initiative, with the goal to help these companies with their space infrastructure and vehicle projects. And while we did discuss these agreements just last week, there was one contract that we wanted to spend some more time on: the contract with Blue Origin, the launch company owned by Amazon founder Jeff Bezos. Like with the other contracts, NASA's partnership with Blue Origin is unfunded and revolves around NASA giving the company their expertise and their research to help in any capacity they can. That is an incredible boost to any space launch company, funding or not, But like we mentioned, 6 other companies are getting the same treatment, so what makes Blue Origin's contract stand out? As it turns out, NASA is helping Blue Origin develop a crewed vehicle for high-frequency US access to orbit, which is extremely interesting. NASA currently has 3 crewed vehicles that are rated for use in orbit for their missions: the Orion capsule made by NASA themselves, Crew Dragon made by SpaceX, and Soyuz made by the Russian space agency Roscosmos. But they have invested in other vehicles such as the Dream Chaser spaceplane made by Sierra Space and the Starliner crew capsule made by Boeing. The problem is that the Orion isn't really meant for rapid use, being as it is an exploration craft made for the Artemis missions, and with the Soyuz being a design from the late 1960s and Russia's increasing unreliability, NASA really only has Dragon to work with for things like crew transfers to the ISS. Dream Chaser could change that, but they're still months away from a potential flight test, and Boeing has been struggling to get their Starliner capsule working for so long that NASA is likely starting to look elsewhere, and that's where Blue Origin comes in. Technically, the company has 2 crew-rated vehicles, the New Shepard and the Blue Moon, which is their prototype lunar lander that's just been contracted to carry the Artemis 5 astronauts to the moon's surface. New Shepard is probably closer to what NASA is looking for with this partnership though. As part of a suborbital launch system, the New Shepard nonetheless flew 22 successful missions before failing back in September 2022, and the launch escape system managed to get the capsule to safety in that instance regardless. That is a pretty good track record, even if NASA needs something hardier than a suborbital tourist capsule. And it's likely Blue Origin has been working on something that is fit for orbital work. Their heavy-lift rocket, the New Glenn, is just about ready for its own test launch and was designed to ferry payloads and vehicles like the Blue Moon lander into space. It's a pretty good bet that Blue Origin could get an orbit-capable crewed capsule ready, especially if NASA lends a hand. Now, there's no guarantee that this partnership comes to anything, but Blue Origin definitely has the resources to compete with SpaceX in this arena. Most importantly, their plans already include partnerships with Sierra Space and Boeing. They are a good company to use this sort of unfunded contract with, and if Boeing ever gets around to getting Starliner working properly, NASA would have access to 3 crew-ready, fast deployment capsules and a spaceplane to boot, which is not a bad stable to keep. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it, that really helps us out for real. And subscribe to the Space Race for more videos just like this. We do 1 long-form essay and 1 news update every week, and if you'd like more, we've got 2 more on the screen for you right now.